In this video, we're going to look at topic 68, example 3, where we solve a system of equations in 3 variables. So that we're asked, how can you solve a system of equations in 3 variables? And we are asked to find the solution for this specific system. Now, there's 3 things you want to keep in mind, or there's 3 things you're allowed to do with systems of equations. You're allowed to rearrange the lists. All right, so you'll see what that means in a second. I could call equation 1 equation 2 and 2 3 and things like that. I'm just allowed to, the order isn't important. All right, note 2 is that I can multiply any equation by a non-zero number. So you would just be changing kind of the factor of that equation. So if I multiplied this entire equation by 2 and increased everything, the equation itself is still representative of the same thing. The numbers are just all going to be 2 times larger in that case. And the third thing you're allowed to do is you can add 2 equations together and use the new equation to replace an old one. Or we'll say to replace a previous one. All right, so if I add equations 1 and 2, I'm allowed to, and create a new one, I'm allowed to use that new one as a replacement for any other ones. And you'll see that comes into play a lot. So I'm going to number these equations. We will call this equation 1, 2, and 3, and I'm going to rewrite those. So 2x plus y minus z equals negative 10. Negative x plus 2y plus z equals 3. And x plus 2y plus 3z equals 13. So again, we're calling those equations 1, 2, and 3. You can use letters. You could say equation A, B, and C, but I'm going to number them. Now, what you want to do in this process, and it's a straightforward process. It does get a bit tedious. Sometimes it is difficult. There's a lot of room for error because you're going to be doing a lot of addition, subtraction, multiplication. So if you do rush through these problems, sometimes you're going to make a mistake with your arithmetic and the whole problem kind of falls apart. So just be careful. And if you follow the procedures, you should be okay. So first thing I'm going to do is I'm going to try to eliminate a variable. You can eliminate x or y or z, whichever one you want. But what I'm going to do is I'm going to take equation 1 and equation 2, and I'm going to add those up. And the reason I'm going to do that is I see that my z's can be canceled out. So they're kind of opposites. I have a negative z and a positive z. So if I was to add up the equations, 2x plus negative x would be 1x, or just x. Y plus 2y would be 3y. The z's drop out, and this would be equal to, so negative 10 plus 3 is negative 7. That's also one of the most common mistakes is people sometimes forget to add up the numbers, the constants on the right, so do be careful with that. So I'm going to get rid of that 1 because I don't need it, and I'm going to call this equation 4. Now I'm going to do the same thing using a different combination. So I'm going to cancel out z again. You always want to cancel out the same variable. But I'm going to either use equations 1 and 3 or 2 and 3. Doesn't really matter which one you pick, as long as you're using 2 of the equations. So I'm going to use 2 and 3. Again, it's not a big deal which one you choose. So I'm going to use equation 2 and equation 3. So negative x plus 2y plus z equals 3, and x plus 2y plus 3z equals 13. Now, it is not important which equations you choose. So again, I could have picked 1 and 3 instead. It is important what variable you cancel out. So I need to eliminate the same variable that I eliminated in this previous step here. So since I eliminated z there, I need to eliminate z again. if I was to add up these two equations, z is not going to cancel out because they're not opposites. So what I want to do is to make them match up, I can use this step 2 or this rule 2 up top here, where I can multiply any equation by a non-zero number. So I'm going to multiply the top equation by a -3, and that way the z's will be, I'll have a -3z and a +3z, and you'll see how that works out. So this would wind up equaling, this -3 has to be distributed to everything. So -3 times -x would be 3x minus 6y minus 3z, and this is where a lot of mistakes are made, so do be careful when you're multiplying these out. So just check to make sure that this is correct. 3x, -6y, -3z, and -9. And then the bottom equation can just come over because, again, we're just trying to cancel out the z's. So plus 2y plus 3z equals 13. And notice now that these z's are opposite. So when I add these equations up, they will drop out. The z's will be eliminated. So 3x plus 3x plus x is 4x. Getting ahead of myself. -6 plus 2y would be -4y. The z's are gone, and this is going to equal to -9 plus 13 would be 4. And we will call this equation 5. Now you'll notice that I have two equations. I'm going to highlight these real quick. Equation 4 and equation 5 both have x and they both have y. There's no z, so I'm now going to use these two equations and work some mathematical magic. So I'm going to take equation 4, I'm going to take equation 4 and equation 5. Equation 4 is x plus 3y equals -7, and equation 5 is 4x minus 4y equals 4. And once again, I'm going to try and eliminate a variable. Doesn't matter if it's x, doesn't matter if it's y, you just want to eliminate something. So let's pick the x's. All right, we're going to get rid of our x's. The x's don't match up. I have an x and a 4x, so I want them to be opposite terms. So when I add them, they cancel out. So I'm going to multiply by a -4, because what will happen when I distribute that out, I get -4x, which will be the opposite of the 4x in equation 5, and I'll be able to eliminate them using addition. So again, be careful with this distribution. -4 times x is -4x. -4 times 3y would be -12y. -7 times -4 is a +28. So I have that equation there, and then this equation, equation 5, is just going to come over as is. Right? I don't need to change it because the whole purpose of this was to match up the x's. Now I can add these two equations up. There is the chance that you have to multiply both equations. So let's say I wanted to get rid of y's here. I would have had to multiply both, but I picked x's, so we're okay. -4x plus 4x, that drops out. That's the whole purpose of this. -12y plus -4y, be very careful with your signs, is -16y, and 28 plus 4 is 32. And now we'll call this equation 6. Right, so now I have an equation with only one variable, which is pretty easy to solve. So I can take this equation 6 and I can solve it. I can just divide both sides by -16, and I get y is equal to -2. And this is a partial answer. Right? This isn't going to be our answer yet, but it is part of our answer. So I know that y is equal to -2. Once I've found one variable, or the value of one variable, I can backward substitute and figure out the other ones. So I want to look for an equation that has a y value and one other variable. So I would then take, let's match up our numbers here. We're going to take y equals -2, and I'm going to plug it back into either equation 4 or 5. It doesn't matter which one you pick. I'm going to select equation 4, which is x plus 3y equals -7. And now I can plug in my y value, sorry, not -4, -2, and I can solve for x. So that y became -2. So x minus 6 equals -7. Add 6 to each side, so x would be equal to a -1. Again, I have part of my answer. So let's highlight that with pink this time. And now that I have x and y, I can solve for z, and I can do that by plugging that into any one of my original equations, equation 1, 2, or 3. It doesn't matter which one you pick. Just be careful substituting, but any one will do. So I'll then take equation, I'm going to pick equation 3 because there's no negatives, so that could make things a little bit easier. So equation 3 is x plus 2y plus 3z, and that's equal to 13. So my x value is going to be -1. My y value I know is -2, and my z value is what I'm trying to figure out now. So -1 minus 4 plus 3z be -5. Now you'll notice, again, these do take a bit of time to do, but if you follow this procedure, you should get them right every time, as long as you're careful with your arithmetic. All right, watch out for your signs, watch out for your substitution, watch out for your addition and subtraction. So my final answer, I want to put these in alphabetical order, so it would be x, y, z, kind of like a coordinate point with 3 pieces. And we're going to say -1. That's not the right marker. So -1, -2, 6. And this is my answer. So it does take a while to get there. You start with 3 variables. You slowly eliminate them. You'll notice that we eliminated z first. So that was actually the last one that we solved for. Then we eliminated x, which was the second one that we solved for. And then y was the one that we never eliminated. So that was the first one that we solved for. Going back up to these rules up here, you're not going to rearrange the list very often. It just is allowed, so I could start rearranging them as long as I keep the values. You're going to use steps 2 and 3, or rules 2 and 3 a lot. You're going to multiply the variables constantly, the equations constantly, and you're always going to be adding up new equations to create a fourth, a fifth, a sixth equation. All right, let's go through that.